Okay, so now we're going to start with a video about the algebraic expressions or descriptions of rotations. So here we have an x-axis and a y-axis, and I'm going to start with a red point, and we'll say this point is x equals 1, 2, 3, 4, 5, and y equals 2. So it's right about there, and it's 5, comma 2. Make it a little bit smaller in the meantime. Okay, and from here, it's some distance, but it really doesn't matter what distance it is right now. Okay, so in order to rotate this, I'm going to rotate it counterclockwise. Counterclockwise, 90 degrees. 90 degrees. Right? Or I could say that I rotated it clockwise 270 degrees. It would be ended up in the same space. So I don't have to really remember one equation. Just remember that it's counterclockwise 90 degrees, or clockwise 270 degrees. So to figure this out, I'm gonna draw a like 90-degree angle, right? Something close to a 90-degree angle, and it's gonna end up somewhere around here, I think. I kind of know because I know where it's gonna end up. But if I had a protractor, it would end up right around there. And you would notice that points would be 5, correction, points would be -2, comma 5 for a counterclockwise 90-degree rotation. So it's a counterclockwise 90-degree rotation. So what you should notice is that the change in x for this, your change in x, your x became your negative y value. And your y, your change in y became your y became your x value. So your x and your y flopped, and your y value became negative. What your originally was your y value became negative, right? So your x ends up being negative, and that makes sense because because you're still above the x-axis, so all your y's are going to be positive. So that should be intuitively obvious for you. Okay, so now we'll show you what it looks like when we rotate it on a table. Okay, if I rotated this yellow here, if I rotated this 5 to the other way, you would notice that it would end up in a 180-degree difference from our blue line, and it would be about, let's see, 1, 2, 3, 4, 5, and then it would end up being right about here, 90-degree angle, clockwise 90-degree direction, clockwise 90 degrees, or a 270-degree counterclockwise rotation, and it would end up being something like this. I guess I could use a straight line tool. We'll use a straight line tool now that I thought about it. Here to here. Okay, and that's the 90-degree angle. Doesn't look that great, but the angle itself, the point itself, is, it says 1, 2, 3, 4, 5. Yep, point itself is 2, -5, and the change in x, our initial x value, became our y value. It became a negative. A change in x, our initial x value became our y value, and our change in y became our negative, became a negative x value. Okay, so our y is now negative, which makes sense. Okay, so algebraically, our description for this one up here, the blue one, would be x, y, would translate, or correction, would rotate to a negative y, negative y, x. This is actually the x and the y coordinate, right? That's a rotation counterclockwise of 90 degrees. So this is saying that this is an x and y coordinate, but it's saying that the x coordinate is negative y, and that the y coordinate is just x. Okay, and this one is x, y, comma, y, and it would shift to rotate to our x coordinate y, comma, negative x. So that's a rotation 90 degrees. So our x coordinate is y, and our y coordinate is a negative the original x. Okay, and then we have a 90 or a 180 degree rotation. That's going to be straight back to -5, 1, 2, 3, 4, 5, and a 2, -2, right? -5, comma, -2, right? So our 180 degree rotation doesn't matter if it's 270 or 180 one way or one way the other way, it still doesn't matter. Notice that our change in x became our negative y, and our change in y became negative. Oh, I'm sorry, that was wrong. Our change in x became negative x, and our change in y became negative y. That would leave our description, algebraic description, be our x and y coordinate, whatever it may be, would rotate to negative x, comma, negative y. So this is just like an equation or like a sentence in Mathenese, right? This describes rotating this point. And if you had a set of points and you applied this Mathenese sentence to all those sets of points, the whole object or the whole figure would rotate. So that's how that whole thing works. So hopefully this helps you understand how these three algebraic descriptions of rotations were derived. Okay, stop that video.